Properties of logs can sometimes help us evaluate expressions that we wouldn't otherwise have been able to evaluate by hand. So for example, if we look at this difference of two logs, we know that the difference of logs is the log of a quotient. So I'm going to match the base. Both of these logs have base 7, and therefore my log, when I combine them, will also have base 7. Writing this as a quotient in the same order as the subtraction, I get 2 over 98 as my input to the log. Of course, that reduces. We have a common factor of 2, which reduces to the log of 1 over 49. Now, remembering how we evaluate logs, I would take the base 7 and ask what power do I raise 7 to get 1 over 49 as a result. The answer to that question is also the value of the log. I know it has to be negative in order to flip the 7 over. It also has to have a 2 in order to square the 7 to get 49, and so this log is equal to negative 2 because 7 to the power negative 2 is equal to 1 over 49. So similarly, we can look at each of these expressions and see what property of logs might apply. Try applying it and see if it helps. In this second case, log to base 8 of 2 might be a little bit difficult to figure out, but because I can apply a property of logs that would have me bring this scalar multiple of 6 up into the exponent of the input of the log, I'll just try rewriting it that way and see if it helps. So that log to base 8 of 2 to the 6th, which I can then evaluate as log to base 8 of 64, I now recognize 64 as being a power of 8. 64 is 8 to the power 2, and therefore this log is equal to 2. Trying the same property with this next one, the power negative 2 moves up into the exponent, so I then get log to base 9 of 3 to the power negative 2, which is the same thing as log to base 9 of 1/9. As 1 over 3 squared becomes 1/9. Again, if it helps, I can take the base and ask what is the power I would raise this base to get 1 over 9. I can see that a power of negative 1 would do the job because the power negative 1 takes the reciprocal of the base, and therefore this log is equal to negative 1. This next example really could be done one of two ways. It is possible to do this using properties of exponents, as I can show you after we've done this doing properties of logs. But looking at a base of 2 and an expression that's a power of 4, because the bases don't match exactly, this one's a little bit harder to figure out. We can simply use a property of exponents though, I'm sorry, a property of logs I mean, and pull that 18 out. And that gets us 18 times log to base 2 of 4. Now log to base 2 of 4 is a pretty easy one. 2 to the power 2 is equal to 4, and therefore 18 times 2 is going to be my result, which is 36. Note that it is possible to do this another way. We could have said, from the beginning, log to the base 2 of 4. Well, 4 is really the same thing as 2 squared to the power 18. And now to indicate that all of this is still inside the argument to the log, I'm going to write this using these brackets. A property of exponents would tell me to multiply these two powers together, which gets 36 here. Then I have log to base 2 of 2 to the 36 which is a straightforward application of a logarithm, also gets me the result 36. So sometimes seeing that we can simplify an expression like this either using a property of logs or using the corresponding property of exponents helps to generate just a little bit more intuitive understanding of how they really are the same property. The property of exponents approach is a little trickier here because we would have had to have the idea of rewriting 4 as 2 squared and then using the property of exponents, whereas just a straightforward application of the property of logs might be just a little bit easier to think of once these properties of logs have become very natural to us. Going on to the last example, we can first combine these two expressions. The difference of logs is the log of a quotient, so I would rewrite this as a single natural log of this quotient 5e squared over 5 times the square root of e. Doing this, I can see that the 5's do in fact drop out. And what I'm left with is 2 powers of e. The square root of e is really a power of e. Remember, this is the same as e to the power 1/2. So now I can use a property of exponents to combine e squared over e to the 1/2, still inside the log at this point. 2 minus 1/2 is the same thing as 4/2 minus 1/2, which is 3/2. So just using the property of exponents that tells me to subtract these powers, I now get natural log of e to the power 3/2. Now, since natural log is log to base e, and we have an expression that is a power of e, I can evaluate this log without any real work. But note that this is again a situation where somebody might have, from this stage, taken the properties of logs approach to finish it. We could also rewrite this as the natural log of e squared minus the natural log of e to the 1/2 to get that this first whole term is equal to 2, this second whole term is equal to 1/2, so that we again find ourselves in this 2 minus 1/2, which is 3/2. We do get to the same answer if at this stage we choose properties of logs instead of choosing properties of exponents.